What's going on, guys? Michael DeMarco back to talk about hybrid cloud and multi-cloud orchestration, leveraging infrastructure as code. Now, one of the biggest challenges for companies today is providing a stable and a scalable remote access solution for their workforce. So in today's demo, we will be deploying a scalable remote access solution in the public cloud on AWS. So in this demo, we can expect to run a Terraform playbook that will deploy our cloud infrastructure and then ultimately deploy our ASAv code. And as a result, we will provide faster time to delivery for the public cloud and securing our public cloud, a more resilient, scalable, and repeatable infrastructure. And not to mention, we're going to enable cross-functional teamwork because it's all about teamwork. Let's go. That it's actually a Cisco referenceable architecture. So this was something that came out during the pandemic to assist customers in scaling their infrastructure to provide their business and their workforce the ability to work remotely. And so we're going to be running through that architecture from a demos perspective and understand the execution and the results and talk through a bit of the code. So I want to first have you familiarize yourself with the what you see on my screen, which is AWS console here. We do have our terminal. It's just a general terminal for Mac, our AnyConnect connection. We're going to test VPN connection. And then we have our actual code here that we will kind of review from a high level. So let's do some verification before just familiarize ourselves with what we are starting with. Currently, we only have one VPC. It's not tied to this demo. It's one of my own, actually. So we will expect that the demo will deploy the script will deploy a VPC. If we head over to our EC2, we are also going to be deploying load balancers. So we will deploy an internal load balancer, an external load balancer that our ASAVs will register to, because part of a scalable solution is a load balancer of some sort, whether that be a network load balancer or a DNS-based load balancing mechanism. Within our EC2 console, if we check our instances, we have two instances there unrelated to our script that we'll be running, but the expectation is that we will have an ASA deployed within here and capable for us to scale and have multiple ASAs. So with that being said, we'll go ahead and execute the script. So we're going to execute our first script. Now this is a series of scripts that actually build upon each other. And that's because they're dynamic in nature. So our first script is going to build our VPC, virtual private cloud, which is just a isolated container for us to provision network resources within the public cloud on AWS. We'll go ahead and execute a deploy.sh. It'll go ahead and do some confirmations for us. It will ask us if we want to proceed with these values within our script. We'll go ahead and say yes to those, of course. And then it will begin creating our VPCs. Our VPCs will be in the network range of 100/100/16. It will provide multiple subnets and build multiple routing tables for us as well. We'll go ahead and wait for that to finish. It has finished, didn't take too long. You can see that it was complete. Awesome. Now, this one takes maybe about 4 minutes to execute in time, so I will be speeding up this video. But we will go ahead and deploy the second script. Again, this is building upon the build out of our VPC. It'll ask us again if we're okay with proceeding with these values in our script. If we check our VPC, we will see that the VPC was successfully created. We have a name of Cloud Edge Terraform and a IP address of 100/100/16, which is what we defined here as well. So our script did complete successfully in about 2 minutes and 30 seconds that we see here, much faster than I thought it actually would. The apply was complete, adding 8 new resources to the public cloud on AWS. One thing that I did want to mention to make sure that you understood was the region at which we were deploying these resources, which is in US East 1 in AWS. So let's go ahead and within the console and verify that our load balancers were created successfully. We have an internal load balancer and we have an external load balancer. Now this is the actual DNS name that we're going to use to connect to our ASAv VPN. So I'll go ahead and copy that out and place it in the VPN. I'll just have it sit there for now. But just to review some of the code, the network load balancer that was created as a NLBO1 external, that's true. The internal one as well. And our next is actually an intermediate step that we need to provide our ASAVs with a 0-day configuration. So those ASA 0-day configurations are derived from this part of the code. And so we will actually build 2 0-day configurations, but we are only going to deploy one ASAV at this time. So ASAV 01 is the only one that we will deploy. And that's because I want to show you the speed at which we can deploy the second one. So we'll generate our 0-day configuration for our ASAs. You can see that they are being built here once we confirm our values. And again, these are registering with the network addresses of the load balancer, which is why they need to be ran in this particular order. If we take a look at what is included in the 0-day configuration, it's fairly standard. It's what you would expect an ASA configuration to have. So we are registering our license to our smart account portal. We have a username and passwords defined. We have access lists. We have the AnyConnect image that we want to deploy to our hosts. This may pose an issue. I am running 410. We'll see how that goes. And our tunnel groups. So this is what you would expect in a normal ASA configuration. Now that we have our 0-day configuration built for us, let's go ahead and comment out this section of code so that when we run the next script, we only deploy one ASA in the cloud. Now, we can expect once this finishes, we should have an ASA instance within our EC2 console. The ASA version we are deploying is 9.15.1.15. Go ahead and confirm these values. Now this is an AMI image, so this is an Amazon machine image. This is owned by Cisco, so this is searchable within the Amazon Marketplace. As you can see here, there are multiples. We have chose this one. So this AMI image ID here and the owner are defined within our script. So this name here is actually what is defined here. And the owner here matches this. Okay, that didn't take too long. We have successfully completed the deployment of our ASA. You saw how quick that was. Go ahead and refresh this list. We have one running ASA, and it is deployed in region A, or excuse me, availability zone A. Region A We are in the East region, but we have deployed our first ASA in AZA. So this is going to take some time for the initialization to succeed. Finished. Our status checks have completed 2 out of 2, which means that we should have the ability to connect to our ASA at this point. So let's try to do so. The public IP is 54.225.110.68. And there we go. So we are connected to our ASA. We do a show run, and it's what you would expect. Now that we've have one deployed within the cloud, let's see how fast we can deploy the second. Let's uncomment this code. We'll go ahead and save that. Because we already have the 0-day configuration for this and nothing has changed, such as the IP addresses, the load balancer, the VPC hasn't changed. Our containers are still the same. Our IP addressing scheme is still the same, right? So we can go ahead and deploy this script again, which is to deploy the ASA instance within AWS. So we'll run the deploy.sh once more. It go through a series of checks. It will realize that it has a second ASAV to configure. We will go ahead and confirm yes, because nothing has changed on ASAV 01. It will stay the same. And again, basic 0-day configuration being applied. We did supply it with a token. This token, it will be used to register to the Smart Account portal, which is where the license for the ASAV will live. And we'll provide it with some VPN pool IP addresses, 192.168.4/24. And while that's completing, it should not take too long. We should be successful in connecting to at least ASAV 01 at this time. So let's make a connection. We will get a certificate warning. I did not load a certificate. That is not best practice, but this is a lab, so that's okay. We will continue forward, and as you can see, we were successful. Now, if we head back to our ASA to check whether or not our VPN landed correctly on our ASA, we can do a little show command, any connect. You can see that we are a username of admin, provided an IP address of 6.1, which matches our address here. And we've been connected for about 18 seconds. So, pretty cool. What's even cooler is that our script is finished and we have added a second ASA that has registered to our public cloud, has registered a network load balancer. You can see how scalable this is and how fast this can grow. Not only that, we deployed it within another availability zone. So redundancy and resiliency is super important in the cloud. So that's the scalable and reliable portion of the Remote Access VPN solution. Super cool. Now, I will say that the load balance in here, this is okay with doing so. Leveraging a network-based load balancer. What's even better and is preferred is leveraging DNS load balancer. So we would leverage an Amazon Route 53. So pretty cool. And I will provide you with the GitHub location. I cannot take credit for this Terraform script. This was built by somebody that did a very good job. I did fork it. There are some prerequisites that you need to successfully execute this. I will provide those for you as well. But it's been an absolute pleasure. I hope you found value in this, in the remote scalable VPN solution in the public cloud.